Right, so here I am in the problems and applications for chapter 2. I got a question about this particular problem, so I'd like to spend a few minutes walking through it. So the question states an economy consists of three workers, Larry, Raphael, and Alex. Each worker has 10 hours a day and can produce two services, mowing lawns and washing cars. And it says that in an hour, Larry can either mow two lawns or wash one car. Raphael can either mow one lawn or wash one car. And Alex can either mow one lawn or wash two cars. So this gives an idea about what they can do and how much time it takes. So the first part of the actual problem is down here in this scenario box or table. So it gives a few different possibilities. One is that all three spend all their time mowing lawns. And it says that that's going to be option A when we come down here and plot this out. There's an A, and that's this little plus symbol. So we're going to think about that in a little bit. But for option A, they're spending all their time mowing lawns. So what do I know about how many cars they're going to wash? The number of cars they're going to wash is going to be 0 because they're not spending any time washing cars. And I'm happy to share that answer with you, right? That one's pretty easy. But how many lawns are they going to mow? I need to figure out a number for here, and I'm not going to tell the answer, but how you go about figuring it out is you could first start with Larry. Well, Larry can mow two lawns in an hour. He works for 10 hours, so 2 times 10 is 20. But 20 is not the answer because it doesn't ask how many lawns can Larry mow. It's Larry and Raphael, so I need to do the same for Raphael, and Alex, so I need to do the same for Alex, and then add those three together. I'll come up with a number in this box. Then I go and I need to find point B, which is all three spend all their time washing cars. So similarly, I know here that lawns mowed should be 0. And to find out how many cars they wash, I go back and do the same process, except now I'm looking at Larry in an hour can wash one car, and so on. And I add it up for all three of the workers. I do something similar for option C, right? C says they spend half their time on each activity. So I figure that out again using the same technique, but here instead of 10 hours for each activity, it would be half, so 5 hours for each activity. And then do something similar for D. Just read this through and work through to figure out how many lawns mowed and cars washed. From that, I'm going to go in and figure out the opportunity cost down here is what this part is asking for each of them. So we've already seen some things about how to figure out opportunity costs, comparing the lawns mowed and cars washed. We've done examples like that with some other things, but you're going to go through it and figure out the opportunity cost there. Now then, the graph, though, presents some extra problems potentially and how to get this out. One thing to note here, though, and I'm going to just highlight something for a moment, is there's this question mark up here at the top. And if you're not familiar with the graphs that appear here in MindTap, you can click on the question mark. It'll open up a new tab, and it'll show you some of the graphing tools and features. So there's that. But the question asks that you're going to need to, or give some instructions. You're going to have to draw something on the picture. So assume that the resources best suited to producing a particular service are preferentially used in the production of that service. So at the beginning here, what we want to note is how many lawns could be mowed if everybody is mowing lawns. So we could go up here, and that would correspond to all three spend all their time mowing lawns. And we're going to put that out. Now, I'm not going to show the correct answer. I'm just going to put that let's say here at 20. I don't think that's the right answer, but just to illustrate what I do, I just drag this and drop it. But then what happens, this question states, what's happening next is then instead of all three of them mowing lawns, I have 2 of them mowing lawns and 1 of them washing cars. And who washes cars first, switches away from mowing lawns to washing cars. It's the person who is best suited to washing cars and least suited to lawn mowing. And so then that spot comes in here. Again, I'm not showing the answer, but just drop that in wherever it is. And then the next point is going to be where there are 2 people washing cars and only 1 mowing lawns. And then there's going to be a 4th point in there where nobody is mowing lawns and everybody's washing cars. And so you'll have a production possibilities frontier out here is what you'll have. So I'm just going to get rid of those. After that, though, what you're going to do is put in these other spot dots, A, B, C, and D, and they're going to correspond. Obviously, I've just dropped them in there in the wrong places, but they're going to correspond to these A, B, C, and D points up here. You have a true-false question. But then, once you have a production possibilities frontier in here, you're asked, are those allocations, the A, B, C, and D, are they efficient or inefficient? Well, let's suppose I don't remember exactly what efficient and inefficient means. So one little just tip, aside from, you can go back to the lecture notes, of course, but you can also go to the book. So if I look over here to the far right, again, let me just highlight that for you. Come over here to the far right, you can click on the full book, and it'll open that up for you. And I know I'm in chapter 2, so I'm going to click on the chapters tab here. I'm going to go to chapter 2, Thinking Like an Economist. And I know I'm dealing with a production possibilities frontier. It even tells me that over here. The production possibilities frontier, blah, blah, blah. So I'm going to look for the section that talks about production possibilities frontier. I come here. It opens up that part of the book for me. And then the last question I had was about, is a particular point efficient or inefficient? So I'm just going to scroll down. I'm looking for those words, efficient and inefficient, and I come right here. An outcome is said to be efficient if the economy is getting all it can from the scarce resources it has available. Points on, rather than inside, the production possibilities frontier represent efficient levels of production. So if it's on the production possibilities frontier, it's efficient. And then it gives an example here. It says point D represents an inefficient. Point D, though, does not refer to the homework problem. It refers to this point D. Up here, let me highlight that for you. This point D in the book. So again, that's not the homework problem, but it explains here, again, if you don't recall from the lecture, what we mean by efficient and inefficient. So I hope that's a little bit helpful for you, and good luck with the homework.